2 of arithmetic sequences and series. We're going to look right now at using sigma notation. Sigma notation is that this is a capital S in Greek, and what it particularly tells you is find the sum. Find the sum of the sequence, or rather the series, from the first term to the 10th term that's defined by this equation. So what we can do is figure out each of the 10 terms and add them all up, and we would use this to help us to find each of the terms. Or we can use one of the sum formulas that we have to help us to be able to do that. Remember that there are two sum formulas that are usually used with arithmetic sequences, or arithmetic series, and it's this form or it's this form. This one's usually easier to use if you can find that information, and we can, given this. So I'm going to use this example of using sigma or summation notation in order to find the sum from the first to the 10th term of this. So if we're going to use that the sum up to a certain number of terms is equal to the number of terms divided by 2, the amount of the first term plus the amount of the last term. Whoops, I put a 2 when I meant to put it there. That means we need to know the number of terms, the amount of the first term, and the amount of the last term. Well, the number of terms, if you count from 1 to 10, the n is going to be equal to 10. There are 10 terms we're looking at. The amount of the first term, the way you figure that out is this k tells you the number of the first term, not the amount, but the number of the first term that you're going to count from. So in this case it really is the first term, and what you do is you put a 1 in there. If k is equal to 1, that means that that's 5 times 1 plus 3. So 5 times 1 is 5 plus 3, that means we have an 8 for the first term. For the amount of the 10th term, because this is k equals 10 for the 10th term, we put 10 in here. So that means the amount of the 10th term is going to be 5 times, let's put 10 in there, plus 3. So it's going to be 50 plus 3. That's going to be a 53. Okay. So now, let's see, let me double check here and think. 10 times 5 is 50. 51, 52, 53. Okay, I think everything's good. We now have the 3 pieces of information that we need, these 3 things. We can say that the sum at the 10th term is equal to 10 over 2. The first term, 8, plus the 10th term, 53. So the sum of the 10th term is 5. 53 and 8 is 61. So when we do 5 times 61, that's 305. So what we're saying here is the sum from the first to the 10th term of the series using this equation, or defined by this equation for each term in it, is 305. Okay, let's do one with a twist in it. I'm going to draw that capital sigma. I'm going to say that x equals 4. I'm going to say 18. I'm going to say 6x minus 1. So this says, this says find the sum of the series from the 4th term to the 18th term that is defined by this equation. So we need to know these things. A1, we need A18. Oh, now wait a minute, we've got a problem. We need A4 because it's 4 in A18. And we need to know the n. So those 3 things we need. So we don't need to know the first term because we're starting with 4. We're starting with the 4th term. I did x here because whether we call this k or n or x, in fact, back to here for a moment, I could have put that as k and k. I did n, so this could have been n too. It just means that the variable there is not related. It is the same variable as this no matter what letter we use. So Doesn't matter we call it X or N or K or J or G or H or whatever. You see periodically different ones like that in their problems. All right, so if I put a 4 in here, 4 times 6 is 24. 24 take away 1 is 23. If I put an 18 in here, now that one's a little bit harder. Okay, so let's see. If I put 18 in here, I get 60, 108 minus 1 is 107. Good. Use a calculator if you can't do it in your head. And even if you do it in your head, be safe in doing a calculator to check, especially if it's a test question. The number of terms is not 18. 18 take away 4, okay, looks like a 14, but it's not 14. N is equal to not 14. It's not just simply 18 minus 4. And here's proof. This was from 1 to 10. That's 10, obviously. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you just did 10 minus 1, you would have made this 9 and you'd have been wrong. So it's not just subtracting. It's counting up, or you could say it's subtracting and adding 1 to make sure you include that 1. Because usually you don't count from the first one. You'd say, oh, 5, 6, 7. But you count the 4 and go up to the 18. So this is actually 15. N equals 15. So what you want to do is, with big numbers, subtract and then add 1. Or count them by finger, which isn't easy when you have large ones. But that means we are going to use the 15 and the 23 and the 107. So the sum of 15 terms, okay, so that's one way to think of it. It's not the 15th term, but from here. So I'm actually going to put it in parentheses and say 14 to 18. It doesn't really matter anyway. You don't even really need to do that. I can just still say Sn. So I will. I'll just say Sn is equal to the number of terms, which that's very important to have that 15, not the 14 some people would do if they weren't really thinking about it. And then the 23 plus the 107. Okay, so that means the sum at the correct number of terms is going to be equal to the 15 over 2, and 23 plus 107 is what, 130? Yeah, 130. And when you multiply that or divide it, or 2 goes into 30, 15, or 130, 65 times, so you have 15 times 65. So the Sn is equal to 975. So these two problems are the same, except that you're starting with the 4th term, and that means you have to be careful of how many actual terms that it is here. Otherwise, it's still done the same way as the other problem that was there. Okay, next thing now is 2 practice problems. First one to find arithmetic means, and then we'll do a second one that's a summation notation problem. So, pause the video and take a few moments to do this problem, and then when you're done, come back to the video, and in about 5 seconds I will start talking on the video, so pause it in the next 5 seconds so you can do this yourself. Okay, now we're all set up here, and I set it up with these numbers showing if it's 4 arithmetic means between them, I put 4 spaces between them. And then I can count how many terms. There's 1, 2, 3, 4, 5, and a 6. So here's a few things that we know. We know that the first term has 2 as the result, and the 6th term has 37 as a result. So what we want to do to find these, similar to what we did in our earlier type of problem, we need to figure out what the difference is. We need to know how much to add to each one of these. If we know how much to add, we can get to this one, then this one, then this one, then this one, and then we would add to get to that one. So we know this information. And in order to do that, we need the D. To get to the D, we will use the basic arithmetic sequence formula, or equation formula. Okay, so we know the amount at a certain term. We know the first term, we just don't know the D. So we're going to use this one in this formula, where this is n, and this is an. So we're going to say 37 is equal to the first term, 2, plus the n is 6, and we don't know the d. But now we can work on all this. 37 is equal to 2 plus 5d. Subtract 2 on both sides, and I get 35 is equal to 5d. Divide by 5, d is 7. So that means now I can do plus 7, and then I can do plus 7, and then I can do plus 7, and I can do plus 7, and I'll verify it by doing plus 7. So that means 2 plus 7 would be 9. 7 plus 9, or 9 plus 7 would be a 16. 16 plus 7 would be a 23. 23 plus 7 would be a 30. And then 7 more would give us a 37. So these four numbers are the correct answer: 9, 16, 23, and 30. Those are the four arithmetic means. Oops, I think I went a little bit below the video page, but now you can see what I'm looking at. A1, A2, A3, A4, A5, and A6, and these two we already had, so the four arithmetic means are these four numbers. Now, time for the second practice problem. It's a summation notation like we just did, and it's where j equals 1, and I'll put a 20 here, to the 20th term. So from the first term to the 20th term, find the sum of the series defined by this equation. Okay, pause the video in the next 5 seconds, go and do the problem, come back, and when you come back I will be starting to talk about this. Alright, so we need to know the first term, we need to know the 20th term, and because it's from 1 to 20, we know that we can actually use that 20. 20 take away 1 is 19 plus 1, or just know that's inclusive. So that means the n is 20 numbers that we're going to be adding up. So for the first term, I'll put a 1 in here. Oh, right one. Is that similar to... no, this is right. 5j plus 3. Put a 1 in here, and that gives me an 8. Similar to the other problem we did in that sense. Now I'm going to put a 20 in here. 20 times 5 is 100. 100 plus 3 is 103. Now we have the information we need in order to do Sn equals n over 2 a1 plus an. So the sum after 20 terms is 20 over 2, and it's 8 plus 103. So the sum at 20 terms is 10 times 111. Getting ahead of myself, because when we multiply by 10, we get that the sum at 20th terms is 1,110. 10 times 111. So those are our two skills I wanted to make sure I covered with you from this section personally, and that's finding arithmetic means and using summation notation to find the sum.